Hey everyone, today we're going to be talking about function notation and how to evaluate functions for given input values and output values. So equations that represent functions are often written in what's called function notation. It's very similar to what we've seen in equations before. So where we have an equation like y equals 4x minus 1, when I write this in function notation, I'm changing the y to f parentheses x. Okay, everything else stays the same. So in function notation, the y changes to what we call f of x. So this is written as f of x is equal to dot, 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 whatever comes after that. So in this case, f of x is equal to 4x minus 1. So when I have it written in this notation, the f of x is the output value. Okay? Because it's the output value, that means that it's the same as the y. Okay, so this part right here is my output. Okay. In function notation, the x inside the parentheses here is my input value. Just like we've seen before, x is my input value. So this is weird in that the input value and the output value can be in the same area. Okay. So we're going to practice with this a little more, and that might make it a little clearer as to what they mean when we have f of x with the output value and the input value. So first we're going to evaluate when they give us the input value. So function notation is especially useful for finding the output value. Remember, the output value is the y value for a given input value. In this case, that's going to be my x. So just like we said, the number inside the parentheses, x, represents the input value. And the resulting value is the output value, which we may also call the y value. So if I'm going to evaluate for a given input value, I'm going to replace the variable with whatever my input value is. So I'm going to replace the variable with the input value. And then I'm going to evaluate or simplify the function. Okay, so let's see what this looks like in action. So we can do these in two different ways. I'm going to show you how to do the parentheses method first. Then I'm going to show you how you can use the table method in Desmos to check your work. So when they give me an input value, okay, when they give me the input value, this is exactly the same as evaluating an expression. So I'm going to write the function exactly the way I see it, but I'm going to replace my variables with open parentheses. Parentheses. Okay, so if I have f of x equals 4x minus 1, well then f of negative 7, remember negative 7 is my input value. I'm going to write the expression exactly the way I see it. 4, x becomes parentheses, minus 1. And then anywhere I see an x, I am going to fill in my input value wherever the parentheses are. So in this case, they gave me the input value of negative 7. So anywhere I had an x, I'm going to replace that with negative 7. Then I'm just going to enter this exactly the way I see it into Desmos or into my calculator. So I'm going to put this part right here into in my case, I'm going to use Desmos, but you can also use a calculator. So I've got 4, parentheses, -7, close it, -1. And when I calculate that, I get f of -7 equals -29. Okay, so remember the whole thing tells me my output value. So f of this tells me my output value. In this case, it's equal to 29. Okay. If I want to use the calculator, or excuse me, the table method, or I want to use Desmos to do this, the process is very similar, but we're going to let Desmos do a lot of the work for us. So the first thing I want to do is type the function in Desmos exactly the way I see it. So in this case, it says f of x equals 4x minus 1. I'm going to type it exactly like that. So f parentheses x equals 4x minus 1. Now this is going to give you a line. That's fine. Remember that we can represent functions as maps, as tables, as graphs. In this case, they're giving you the graph and the equation. Then I'm going to touch this gear icon right here. It looks like this. Okay. I'm going to touch that gear icon right there. And now it's going to give me the option to change it to a table, copy it, or close out of it. I want to click on that table button. I want this to give me a table for my function. So what this has done is Desmos is taking each of these input values, x equals -2, x equals -1, x equals 0, x equals 1, x equals 2, and it's constantly evaluating these. It's plugging those in exactly the same as we just did. So because it knows that the input value is going to go here, well, I can just type my input value. The input value that they gave me was -7. So all I have to do is put it in the table, and it tells me what my y value is. In this case, my output value, my y, is -29. Okay, this is a great way to check your work. So let's look at one more. We'll do it by hand, and then I'll let you practice one. So in this one, they give me the input value. I know that because the number is inside the parentheses. So this is my input value. Okay, so I can change anywhere I see an x to a 9. So I want f of 9, which means I keep the function exactly the way I see it. Anywhere I have an x, I'm going to replace it with parentheses, and then my -1 is there. Inside my parentheses, I want to put 9, and now I can evaluate this. Okay, this whole f of 9 part can just come straight down. Remember that the f of whatever represents your output value. So I multiply first. 2/3 times 9. I can do that right in Desmos or in my calculator. So 2/3 times 9 gives me 6 minus 1. 6 minus 1 equals 5. So in this case, I get f of 9 equals 5. So my input value was 9. My output value is 5. Okay. I can check this in Desmos. I can do that by typing my function exactly the way I see it written in the question. So I've got f of x, f parentheses x, equals 2/3 x minus 1. So all I did was I took the function they give me and I put it in Desmos. Now I press the gear button and then click table to make a table out of this equation. You can see they've already filled in some input values, but I'm interested in where the input value is 9. So I'm just going to go ahead and type 9 into one of these rows, and it's going to give me my output value in the Y place. So 9 was my input, 5 is my output. That's what I got, so we're good there. Go ahead and try the second one. If f of x equals x squared minus x, find f of -4. I want you to try it by hand first, check your answer in Desmos, and then come check your answers back with mine. All right, so when you plug this in, remember that you're leaving everything the same. So I've got my square, my minus, but where I have any variables, I'm going to put parentheses. So where my x was, I put some parentheses there. Where this x was, I put some parentheses there. And I'm going to plug in my input anywhere I had an x. So I can calculate this by hand. Remember to use parentheses when you do this exponent. -4 squared is +16. If you forget those parentheses, you're going to get -16. So make sure you're using parentheses when you plug this in. So -4 squared is +16 minus -4. 16 minus -4 is 20. I can check this in Desmos. I'm going to type it in exactly the way I see it given in my problem. So this function right here, I've got f of x equals x squared minus x. Again, it gives you the graph of what that looks like. I want to press the gear wheel and table so that it gives me a table for this value, for this function. And in this case, I want my input value to be -4. So all I'm going to do is put my input in that x place of -4. And it tells me that my output value is then 20. So my input was -4. I typed that in right here in my table, and it gave me my output that corresponds, which in this case is 20. So that's if they give me the x value. They give me the input value to work with. But sometimes in function notation, they'll actually give you the output value. So remember that the output value is your y value. So what you're looking for in this case, your job is to find what input value, so what x, is going to give you the output value. Okay? So, like in this example, f of x equals 4x minus 1. They want you to find f of x equals 19. Now, that 19 is not in my parentheses. It is not my input value. So I know my output value, y equals 19. Okay? But I do not know my input value, right? They don't give me one. So that's what I need to find out, is what is my input value if I want my output value to be 19. So the first way we can do this is we can solve the equation. We do that by writing the function exactly as I see it, but I want to replace my variables. Nope, I want to replace my f of x with whatever the output value they gave me was. Okay, so this is the same concept. They told me that f of x is 19. So when I rewrite this, I can write this as 19 equals all of this, 4x minus 1. I still don't know what x is. That's what I'm looking for. So the first way I can solve this is by solving it the same way I would solve any other equation. I'm hoping to get x by itself, so I'm going to add 1 to both sides. I get 20 equals 4x, and then I divide by 4 to get x alone. So I get 5 equals x. Remember that x is our input value, and that's what I'm looking for here. Okay, so my input, I want x equal to 5. Okay, so you can do this by hand if you remember how to solve equations. If you don't remember how to solve equations, we can use Desmos to try to do this instead. So just like before, I'm going to enter my function, exactly the way I see it in the problem. So f of x equals 4x minus 1. F of x equals 4x minus 1. Again, I can do the gear wheel and the table so that it's going to make me a table of this. Now, I'm looking for my output value. Remember, they gave me my y value right here. They said y equals 19. F of x equals 19. So I'm looking for where is f of x 19. The easiest way to do this is with some trial and error. So I can get rid of my x value there, and I'm just going to try a bunch of x values. So if I try 2, I get 7. Well, I'm looking for it to be 19. So it's not quite big enough. Let's try 3. 7 went up to 11. That's good. So 3 is, we're getting bigger. What if I try 4? When I do 4, I get 15. I'm still getting bigger. I'm getting close to what my output value is. Let's try 5. 5 gives me 19. Remember, they told me what I'm looking for. I'm looking for f of x to equal 19. So as I go through Desmos, I'm waiting to see 19 in that output value place. Okay, I'm looking for where f of x is 19. I found that when I plugged in x equals 5. So in this case, my input value is going to be 5. Okay, that will come with practice. But let's try a couple of these. I'm going to just do them in Desmos because we haven't quite solved yet in this class. So we're going to try these in Desmos so that we can get a feel for what that looks like. So given the function, f of x equals 2x plus 1. So there's my function. We're good there. Find the value of the domain. So we got to think a little bit about this one. Find the value of the domain. That is my x value. Let me highlight that. Find the value of the domain. So I am looking for x. Okay, they say, what is the domain? Remember, the domain is the x value, so I'm looking for x here. When the range is 3. So they tell me that y equals negative 3. Excuse me, when the range is negative 3. I'm looking for where y equals 3. So I'm going to use Desmos here. Open it up over here. I'm going to type my expression exactly the way I see it. So in this case, I've got 2x plus 1. So f of x equals 2x plus 1. And I'm looking for where y equals negative 3. They gave me the range. They gave me the y value. So I'm going to do the gear wheel. I'm going to make a table. Do I see anything that has negative 3 yet? I've got 5, 3, 1, negative 3. So I'm looking for where y is negative 3. Well, fortunately, this one already has negative 3 on my table. I'm looking for where y, the range, equals negative 3. That's what I'm looking for. I find it right here. The x value with that is negative 2. So in this case, x equals negative 2. Okay. You may also see this written as f of negative 2. Remember, that's my input value, equals 3 as my output value. Okay. In this one, they gave us y. We were looking for x. Go ahead and try number 2 on your own. Remember, you're going to take this equation, this function, you're going to plug it in Desmos, and you're looking for where f of x equals negative 6. So where is y equal to negative 6? I'm looking for what is x. Okay, go ahead and try that in Desmos, see if you can come up with x, and then come back here and check your answer. All right, so for number 2, they give you y equals negative 6. So I'm going to type this into Desmos, and I'm looking in the table for where -6 is in my y column. It's in my f of x column. It's in my right-hand column. Well, when I do this at first, I don't have anything that says -6 here. Looking at my y values, I've got -5, -4, -3, -2, -1. None of those are working for me. So I need to try some other stuff. I can try 3. Let's say I tried 3 and that. See if that works for me. No, that gives me 0. That's too high. Let's try -3. So in this one, I get -6. That's what I'm looking for. So I'm looking for where y is -6. When y is -6, x is 3. Excuse me, -3. So in this case, x equals -3 is what I'm looking for. You may see it written as x equals -3. You may say it written as f of -3. Remember, your input value goes inside the parentheses. Equals -6, the output value that they gave me. Okay. What I want you to do now is try these 4. Remember that in some of them, they give you the input value, and in others, they give you the output value. So take a look. You can try them by hand. You can try them in Desmos, but I want you to give each of these a try and pause your video, try these, and come back and check your answers with me when you're done. All right, for number 1, you're looking for x. They give you f of x equals 9. So when they give you f of x equals 9, that means that the output value or the y value is 9. So I'm going to type in exactly what I see for my function. So they told me that f of x equals 1/2 x plus 7. So I'm going to type that in Desmos. F of x equals 1/2 x plus 7. And then I'm going to use my table, press the gear wheel, press the table, to figure out where y equals 9. Okay, they gave me the output value, so I'm looking for where is f of x equal to 9. That's right out of the problem. Well, I've got 6, 6.5, 7, 7.5, so 9 isn't on here yet, but I'm getting closer and closer and closer to 9. So I tried 1, 2, let's try 3. That gives me 8.5, not quite where I'm at yet. Then I'm going to try 4, and that's when I get my y equals 9. So f of x equals 9 is right here, which means my x, or my input value, is 4. Okay, so you can write it as 4 equals x. You can write f of 4 equals 9. Either way is okay, but you need to specify that the input value is 4. All right. Number 2, given the function f of x equals x squared minus 8, what is the value of the range? So they're asking for the y. Remember that the range is the y value. What is the range when the domain is -5? So they already give you x. This is good. When they already give you x, or they already give you the input value, all you have to do is plug it into the function. So I've got f of -5, and then anywhere I had an x, I plugged in that -5 with my parentheses. When I solve that, I should get f of -5 equals 17. They already gave me the input value. I'm finding the output value. For number 3, they give me the output value. Find, or if f of x equals 2 times x minus 3 over 2, find f of x equals 4. They give you the output value, so I want to use Desmos here. I'm going to follow the same process. I'm going to type my expression or my function exactly the way that I see it into Desmos. Okay, so I'm going to type f of x equals, I'm going to do my division sign first so that I can open up that fraction. 2 parentheses x minus 3. Close those parentheses, and on the bottom, I'm going to put 2. So I've typed it exactly the way I see it. I'm looking for where f of x equals 4. So I'm going to do my gear wheel. I'm going to make a table, and I'm looking for where does f of x equal 4? Well, taking a look at my table, and I'm not seeing any 4 yet. But I noticed that as I'm getting bigger numbers, they're getting bigger. So 2 didn't work, but let's try 3. 3 gives me 0. So let's try 4. Let's try 5. Maybe let's try 10. Oh, too big there. So maybe 6. 6 gives me 3. 7 gives me 4. So I'm looking for my y or my f of x or my output value to equal 4. It does when x is equal to 7. So on your paper, you can write x equals 7. You can write f of 7, my input value, equals 4, my output value. Either of those is okay. You have to recognize that 4 is the y, 4 is the output value, 7 is the input value that makes that output value work. Okay? So for number 4, this one is another one where they give you the input. If f of x equals x squared plus 3x plus 1, find f of 2. They give you the input. So I'm going to write my function exactly the way I see it. Anywhere I have x's, I'm going to put some parentheses, and then I'm going to plug that 2 into those parentheses. Now, once you get to this step, remember that you can just put it in Desmos from here. Okay, just leave off this part. Okay, just type your expression afterwards. Okay, but if you want to simplify this by hand, you can do that as well. Either way, you should get that y equals 11 when x is 2. So f of 2 equals 11. If you have any questions, make sure you write them down. We'll go over these in class.